Hello friends, welcome to Techmine Guru. I'm your coach Supratim. Today we are going to dive straight into lecture 22, where we will be covering hashing basics. We are going to explore the art of optimization and fast lookups. And by the end of this session, you will understand exactly what hashing is, what is the difference between HashMaps and HashSets, and lastly, we will see some DSA problems on arrays solved using HashMaps and HashSets. So let's start with a practical scenario, the Radisson Hotel. Imagine you manage a hotel with exactly 5 rooms. To check occupancy, we just use a simple Boolean array. The massive advantage here is that searching takes exactly O of 1 time. But let's look at what happens after the pandemic. Suppose the hotel expands from 1000 rooms to 1 billion rooms. If we create a Boolean array of room of 10 to the power 9 plus 1, we will run into a major problem. That is the space wastage. The space wastage will be huge, as millions of empty slots of memory are reserved but never used. The result in a OM in space complexity, since it will be order of O of 10 to the power 9, right? So to fix this, we will enter the hash map. So there are few basic rules to understand here. A hash map stores key value pairs. The keys should be unique and the values can be anything. So the beauty of this structure is that it gives us a time complexity of O of 1 to search and space complexity of O of n to store n entries. So let's do some quick hash map design quizzes to log this in. Suppose your use case is to store population of every country. In that case, you will use hash map of string comma long. So your key will be country and your value will be population, which can be in int or long. Next, let's suppose you have to store the total number of states per country. Just you have to keep the count of states per country. So you will take a hash map of string comma int, right? So the key will be country name and value will be the count of states in that particular country. Similarly, if you have to store the name of all states per country, in that case, you will take an hash map of string comma list of string. So the key will be unique here, which will be the country name, and we are using the value as list of string so that we can keep all the states for that particular country. Now let's understand what is a hash set. Unlike a map, it only stores keys, right? So these keys have to be unique and they can only be of primitive data type. Now let's compare hash map versus hash set. So how will you calculate the size of a hash map? It will be number of keys present. Similarly, in case of hash set, it is again number of keys present. How will you insert an element in a hash map? Using insert key comma value. So the insert function in hash map will take 2 parameters. One will be key and the second will be the value for that key. But in hash set, we will only insert key because hash set only keeps key and not values. So when you search a key, at that time hash map will return a value for that particular key. But in case of hash set, when you search a key, it will only return whether that key is present or not using Boolean values like true or false. And when you want to delete a key, you will just call delete key for both hash map and hash set. And finally, if you want to update a key's value, you will use update function with key comma the updated value. And the best part is all this operation will be of O of 1 only. Depending on your preferred programming language, the libraries differ slightly. So in Java, when you have to implement HashMap, you will use this HashMap class. Similarly, for implementing HashSet, you will use this HashSet class. In C++, you have to use unordered map for HashMap and you have to use unordered set for the HashSet. Similarly, in Python, you will use dict for HashMap and for HashSet, you will use set function. Similarly, in JavaScript, you will use map for implementing HashMap and set for implementing HashSet. And similarly, in C# you will use dictionary and HashSet class. So let's see some DSA problems on array where we can apply both of these concepts of HashMap and HashSet. So the first question is, you have been given an array of n elements and q queries, and you have to find the frequency of the given element in the query. So suppose the array is 2, 6, 6, 3, 8, 2, 8, 2, 3, 8, 10, 6. So if in the query, you have to find the frequency for 2, how many 2s are there? 1, 2, and 3, right? So the answer will be 3. Similarly, if you have to count how many 8 are present, it will be 1, 2, and 3, right? Similarly, if the query says that you have to count number of 5s, what is the frequency of the 5s? If you see the array, there is no 5 present, so the frequency will be 0. Suppose in the question, the given constant is n is lesser than equal to 10 to the power 5, and query is also 10 to the power 5, and each array element limit is starting from 1 to 10 to the power 7. So if we approach through the brute force, which will give us the time complexity as O of Q cross N, will definitely give us a TLE. So let's see how we can optimize the same. So for optimizing, we just need to pre-calculate all the frequencies, and after pre-calculating, we just need to get the value for that particular key. So for the pre-computation part, you will run a loop for I is equal to 0 to n minus 1. You will check whether that particular element is present in the hash map or not. If it is present, you have to increase the frequency of that, and if it is not present, you have to insert that element in the hash map with the frequency 1. Now in the second part, you will just run a loop for I is equal to 0 to q minus 1. You will check in the hash map whether that particular query element is present or not. If it is present, you will print the frequency, or else you will print 0, right? So let's do a dry run of the same. So suppose you are at 26638228238238106. So when you pre-calculate everything, it will give us 2 as 3 frequency, 8 as 3 frequency, 6 as 2 frequency, 10 as 1 frequency, and 3 as 2 frequency. Now suppose you have been given the query 2. So you will check whether in hash map 2 is present or not. It is present, so it will print the value. So what is the value for the query 2? It will be 3. Similarly, for the next query 8, you will again check in the hash map whether that 8 is present or not. And if it is present, you will simply print the frequency of that element, which will be 3 again. In the next query, you have 5. So you will check in the hash map whether 5 is present or not. It will say the 5 is not present in the hash map, right? So it will print 0. So if you see the time complexity here, so this will give us the time complexity of O of n, right? And this will give us the time complexity of O of q. So what will be our total time complexity? O of n plus q. And since we are taking hash map, which will take space complexity as O of n, so our space complexity will be O of n. Now let's see the second problem of our day-to-day, which is to count distinct elements. So you have been given an array, and you have to count the distinct element present in the array. So you don't need hash map for this. You can simply do this by keeping the elements in the hash set, because in the hash set, it will never contain duplicate element. So if you see the code here, we have initialized hash set int, and after that, we ran a loop for I is equal to 0 to n minus 1, and we simply inserted all the array elements into our hash set. Since hash set internally will not keep duplicate elements, so for this array, it will remove one of the 5. And finally, we will print the size of the hash set, which will tell the count of distinct elements. So this is a lead code problem. The link I have mentioned in the description as well. Now let's see one more interesting problem, which is pair sum equal to k exists or not. So in this question, the question says you have to check if there exists a pair I comma j such that a of I plus a of j is equal to k, and k is our target element. Suppose the array given is a is equal to 8, 9, 1, minus 2, 4, 5, 11, minus 6, and 4. And suppose the k is given as 6. So if you see the second element and the fifth element, these two can give us one pair which is equal to 6. Since a of 2 is 1 and a of 5 is 5. 1 plus 5 is 6. So we got the target element, and we will exit from this code. So we will return a true here. Suppose k is given as 22. So if you see, you will see that there is no pair exists which can result in 22. So in this case, it will be false. Now, in the third example, suppose k is 8. So if you see the fourth element and the eighth element, you will see that a of 4 plus a of 8 will give us 8. So this will return true. So if you try to apply the brute force logic here by checking a of j is equal to k minus a of I using two nested loops, your time complexity will be O of n square, and your space complexity will be O of 1. But we need to optimize this, since we can do this in a better approach. So what we can do here is that we can keep everything into the hash set and then check whether k minus a of I exists or not. Since our original expression says that a of I plus a of j is equal to k, that means if we want to express a of j, it can be expressed as k minus a of I, right? So suppose if we insert it into a hash set, then check if k minus a of I exists or not. Suppose our array is 8, 9, 2, minus 2, 4, 5, 11, minus 6, and 4. So in the hash set, you will insert everything, right? So this 4 is repeating, you will not insert it, right? So in your hash set, it will be 8, 9, 2, minus 2, 4, 5, 11, and minus 6. And suppose your target k is 4 only. So when your array will move till this second element, which is 2, your target element will be k minus a of I, which is again 2. So if you have already kept this in the hash set, this will tell that 2 is present in the hash set. But if you see, you can observe that to achieve the target k is equal to 4, you don't have second 2 present in the array, right? But using this approach, you will get that yes, 2 is present in the hash set. So although it will be an ON approach, but still you will get a wrong answer because you use the same element at index 2 twice. So to fix this, we can slightly modify our approach. So now our approach will be, so as you go in the array, you keep on storing the elements in the hash set, so that in that way, we do not check the same element again and again. So the idea is to store only 0 to I minus 1th element when you are at ith index. So suppose the array is same 8, 9, 2, minus 2, 4, 5, 11, minus 6, and 4. And this time the target is 9. So when you are index 4, that is, if the element is 4, your target will be 5. But in your current hash set, what all values will be there? 8, 9, 2, and minus 2. Since you are at index 4, so in the hash set, only 0 to I minus 1th element are present. So 5 is not found, right? And also, if you see that till now, we have not got any pair of 4 with which on adding the same, we can get the result k is equal to 9. Then after that, we will move to the next element, which is 5. Now the target element will be 4. And when you move till 5, in your hash set, you will have 8, 9, 2, minus 2, and 4. So this target element can be found in the hash set. And also, if you see by the array that when you move that 5, the 5 can make pair with 4 and tell whether that pair is present or not. So this is the code implementation for the same. We have initialized an hash set of int. Then we will run a loop from for I is equal to 0 to n minus 1. We will check in the hash set whether that target element is present or not. So since this if condition is present inside the for loop only, so it's like we are tracking as we go. So it's like when you are at index I, it will have 0 to I minus 1th element present in the hash set, right? So in this, we are checking whether the target element is present in hash set or not. If it is present, we will simply return true. Or if it is not present, then we will insert that element in the hash set. And as soon as we get the target element, we will return true. And if we not get any target element, at last from our loop, we will come out and we will return false. So since we are running one for loop only, so our time complexity will be O of n. And since we are using hash set, so our space complexity will be O of n only. So let's now see an extension of the above problem. So what if the question says that you have to count all pairs present in the array whose sum is equal to k. So you will be given array n and k, and you have to count pairs I comma j where I is not equal to j and a of I plus a of j is equal to k. So in the previous question, you have to check whether that any pair is present or not. So in that case, we don't need to iterate the complete array. As soon as we get a pair, we can simply come out of the loop saying that the pair is present. But in this question, you have to count such pairs. So you cannot use hash set here because hash set will only tell if that complement exists or not. So in this, we need to know how many times we have seen that complement in the hash set. So for this, we need to keep the elements with their frequencies. So for that, we need a hash map so that we can track frequencies as we travel. So suppose you have been given an array 2, 5, 2, 5, 8, 5, 8, and the k is 10, right? So one pair will be this 5 with this 5, one pair will be this 5 with this 5, and one pair will be this 5 and this 5. So this will create 3 pairs, right? Similarly, this 2 will pair with this 8, this 2 will pair with this 8, so it will be 3 plus 2, and similarly, this 2 will make pair with this 8, and this 2 will make pair with this 8 as well. So again, it will be plus 2. So how many pairs will be present? It will be 3 plus 2 plus 2, which will be 7 pairs present. So if you see the code implementation, so first we are initializing an hash map with int comma int. So the key here will be the element and the value here will be the frequency of that element present. So we have taken an answer variable to count number of pairs. Now we are running a for loop from for I is equal to 0 to n minus 1. Now our target is k minus a of I. We are checking in the hash map whether that target element is present or not. If it is present, we will add that into our answer so that we can get the count. And finally, when we will come out of this hash map, we will simply update the frequency of that current element. So if you see, what is the time complexity here? since we are running only one for loop from for I is equal to 0 to n minus 1, so the time complexity is O of n. And since we are taking HashMap, whose space complexity is O of n only. So let's see that with the dry run. So this is the array 2, 5, 2, 5, 8, 5, 2, 8. So when you are at index 0, what is your target element? 8, right? So in our HashMap, did we have any 8? No. So we will just update the HashMap with the frequency of the element as 2 as 1. Now we will move to 5. So our target element will be 5. So do we have any 5 present in the HashMap? No. So we will simply update the HashMap with 5:1. Next, we will again see 2. So our target element is 8. So do we have any 8 in the HashMap? No. But in this case, we have the element 2 present in the HashMap. So we will update the count from 1 to 2. Similarly, when we will come across again 5, the target element will be 5. And here we already have a 5 present in the array. So here we will add 1 into our answer, right? And since the element is 5 only, so after updating the answer, we will update our frequency for 5, which will now become from 1 to 2. And next, we will move to 8. This time, our target will be 2, right? And we will check in the HashMap whether 2 is present or not. Yes, 2 is present and its frequency is 2. So if you have observed till here that when we reached 8, we have 2 2s before that, which can make 2 pairs, which can result in k is equal to 10. 1 2 with this 8 and 1 this 2 with this 8. And now, since this 8 is not present in the HashMap, we will update our HashMap with 8:1, since 8 appeared first time. Now again, we will move to this 5. This time, it will check whether the 5 is present in the HashMap or not. This time, the target element is 5. We will check whether the target element is present in the HashMap or not. It will say yes, and it will add the frequency of the target element. And since 5 appeared third time in the array, the frequency will now become 3 for 5. Now we will move to 2. Now the target element will be 8. And we can see in our HashMap that 8 is present one time. So we will add 1 into the answer. And since element 2 is already present in the HashMap, we will increase the frequency from 2 to 3. So if you closely observe till here, you have 3 2s and 1 8, right? So all these 3 2s will make one pair each with the 8. And similarly, we have 3 5s. And these 3 5s make 3 pairs with each other, right? So after that, we will move to the last element 8. This time, the target is 2, right? We will check in the HashMap whether that 2 is present or not. We will see that there are 3 frequency of 2 present. So we will add 3 into our final answer. And we will also see that 8 is already present in the HashMap. We will increase the count from 1 to 2. So now if you closely observe, you have 3 2s present and 2 8s present. So each 2 will make one pair with each 8, right? So this 3 2 will make pair with this 8, and this again, this 3 2 will make pair with this 8. So in total, there will be 3 plus 3, 6, 2 8, 2 8 pairs. And we already saw that how we are getting 3 pairs from 3 5s. So in total, you will get 9 as the total count of pairs where target k is equal to 10. So to wrap things up, keep this hashing cheat sheet in mind. For element frequency, the best structure is a hash map because it needs to map an element to its count. So for distinct element, we use a hash set because it will automatically reject the duplicate element. Next, to check if a pair sum exists or not, we have to use a hash set and we have to track as we go, because in this, we only need to know if the complement exists or not. And finally, in the count pair sum, we will use a hash map, and again, we will track as we go, because in this, you need to know how many such complements exist in the array. So congratulations, guys. So today, you have mastered hash maps and HashSet. So if you found this video insightful, hit that like button and subscribe to Techmine Guru. In the next lecture, we will solve some advanced interview problems on hash maps and HashSets. With this, signing off for today. Till we meet again, keep coding, keep learning, and keep optimizing.